Hello, my friends. Today we are looking at a t-test, which is a form of hypothesis testing. So for this first example, we have the manager of a restaurant chain going to a seafood wholesaler, inspects a large catch of over 50,000 prawns, and we know that the population is normally distributed in terms of their weight. We're going to buy that catch if the mean weight exceeds 55 grams per prawn. A random sample of 60 prawns is taken. Obviously, we're not going to sit there and weigh 50,000 prawns. The sample mean is 56.2 grams for the weight, and then the standard deviation 4.2. And then we're conducting a one-tailed hypothesis test with significance level of 5%. 5% is our most common. And we're going to determine whether the manager should purchase the catch. So our very first step is stating the null and alternative hypotheses. Okay, the null hypothesis is basically that nothing happened. The alternate hypothesis is usually our action. So they're both going to have mu. For the null hypothesis, it's always mu equals something. And then for the alternate, it's always mu less than, greater than, or not equals the same number. So our decision factor is based on the weight of the prawns, and we're only going to buy them if the mean weight is 55 grams or over 55 grams. Okay, so our null hypothesis is that they weigh 55 grams. So putting this into words, we would say the mean weight of the prawns is 55 grams. Okay, because we're only going to buy it if they weigh more than 55 grams on average. So that would mean our alternate hypothesis is mu greater than 55. Okay, alternate hypothesis statement is 99% of the time words straight from the question. Okay, so I'm straight up going to copy the mean weight exceeds 55 grams per prawn. Completely plagiarized from that part in purple. Okay, significance level alpha is the value that we are testing against. Usually it's 5%. Sometimes we see like 1%, 2%, sometimes maybe 10, but it's usually 5%. And for this problem as well, it's 5%. So 0.05. All right, and then on our practice Google Sheet, we have a table to fill in. So we're just going to fill in our variables. So our sample size, which is letter N, is the number of prawns that we took out and weighed. And in the problem, it tells us we weighed 60 prawns. The sample mean is the average that we get from our test. So from weighing those 60 prawns, we got a mean weight of 56.2. The sample standard deviation, pretty self-explanatory, the deviation from the sample. Okay, those are given from the problem. Our hypothesized mean is the mean that we're testing against, which is the one that we say is either equal to or mu is greater than. The next part we're going to fill in is the test statistic T, which is one of these instances where the handheld graphing calculator is a little bit more efficient, but we can still calculate this on Google Sheets. So I'm going to use the formula. And to get Sheets to calculate that, remember the first thing that I'm always going to type in is an equal sign. That's the signal that we are doing math. I'm going to use parentheses for the top of my fraction. And for my formula, I have sample mean minus the hypothesized mean. So x bar minus mu. I'm being a little bit fancy by clicking the values instead of typing them in. You could type them in, or if you feel comfortable, you can click on the values. Okay, and then the bottom half of our fraction is standard deviation divided by the square root of the sample size. So I'm going to type in SQRT. That is the signal to take the square root in Sheets, and our sample size was 60. All right, so I have double parentheses at the end because I had to close the parentheses for the square root as well as close the parentheses for the bottom of the fraction. And we get the value of 2.21. Okay, we need this secondary value called degrees of freedom. Again, this is a little bit quicker if you're on the graphing calculator, but we can do it in sheets. So the degrees of freedom is just the sample size minus 1. Sample size is 60, subtract 1, 59 degrees of freedom. All right, for the p-value, this is where we're going to use our fancy formula, which is t.dist, and then there's a couple other options that pop up, and we're going to break that down, but I'll show you one more time. I start with an equal sign to tell sheets that we're doing math, and then I'm going to type t.dist, and then these are my different options. I have a right-tailed distribution, I have the two-tailed distribution, and then the left-tailed. Okay, this depends on what direction I'm testing. In this case, let me click off of the formula so I can click something else. In this case, I'm testing greater than 55. If we're going greater than 55, that means I'm moving on the number line to the right, because that's the direction in which numbers get bigger. So that means I need to use the right-tailed test. The right-tailed distribution is going to show me everything above 55. Okay? Okay, once I have the correct formula, all that I have to enter within it is the test statistic t, so that value that we calculated, and then comma, degrees of freedom. And then I'm going to close the parentheses for the formula and hit enter. And then I get my p-value of 0.0154. Okay. Now that we've calculated the p-value, we compare this to our significance level alpha, which we have written up above here. And remember, in order to move on to our action or our alternate hypothesis, we need to be able to reject the null hypothesis, H naught. We reject it if our p-value is less than alpha. So in this case, I got a p-value of 0.0154, which is definitely smaller than 0.05. So p is less than alpha, which means we can reject the null hypothesis, and thusly, we can accept the alternate. All right, and that's fun, but that kind of means nothing. So then our next step is to put that in the context of what we're actually talking about. Okay, the manager is only going to buy the catch if the mean weight exceeds 55 grams per prawn. And since we've rejected the null hypothesis, we can now accept the alternate hypothesis. So we can assume that the mean weight is over 55 grams per prawn. So this is a sample we want to buy. All right, so we're going to write our conclusion in sentence form, and you know with word problems I love in all capital so we're going to say, so the manager should buy the catch because the mean weight of the prawns is over 55 grams. And then I like to be a little bit extra, and maybe I'll color in my final statement. Maybe I'll also color in my p-value just to help things stand out if I feel like it. So that was a rather slow, but hopefully really, really clear step-by-step of how we can perform a t-test to either accept or reject a hypothesis. The next thing that we're going to look at in the next video is how to perform this on a graphing calculator. It is a little bit faster on the calculator, but it also kind of looks a little bit more like magic on the calculator. So we will check that out next time. Thank you.